Good morning, dear students. Before we will start today's video, there are 2-3 correction in the namings which I have already given, and please do that correction. It was brought to my notice from your friends only, so please take care for it. Page number 18, and we have ch2, ch2, ch2. Right? So here on first and third alcohol group is there. So name should be 1,2,3 propane, 1,3-diol, where I have written 1,2-diol. So this will be 3. This is the correction in page number 18. Right? And now let us see the names for the compound which I have given yesterday. So on page number 22, 5 questions I have given. Here 1, 2, 3, 4, 5, 6, 7. So when we continue chain, we will find here longest continuous chain, then there are 7 carbon from this side or from this side, because it is a straight chain, no branches there. But now question is there from where we will give the numbering. So one rule is there, when double bond and triple bond is present, double bond will be given preference first. So our numbering will start from left hand side. So here 1, 2, 3, 4, 5, 6 and 7. So the main parent word here, it will be, branch is not there, so parent word will take place. So 7 carbon, so hapt. Now 1 and 2 on second carbon, double bond is there, so 2 in, and then where is third? A triple bond, so 3, 4, 5. On fifth it is triple bond, so it will be 5I. So what is the name? Hapt 2 in 5I. Right? Now let us see the next. How many carbons are there in a straight or in a continuous chain? So if we start from here, it is 1, 2, 3, 4, 5, 6, 7. If we continuously consider this, then it is 7. Now let us see 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we consider this, then there are total longest chain of 9 carbon. Now here you see double bond is there as well as triple bond, right? I have triple bond, but here this is not a triple bond. Again, your friend only brought it to my notice. See, carbon satisfy 4 valency, so tetravalent. So it must have 4 valency satisfied, 1, 2, 3 and 4. But here what happens? See, by mistake, 1, 2, 3, 4, 5, 6. So please cancel 2 bonds. Here it will be only a single bond, right? Not triple bond. So here aldehyde group is there, alcohol group is there, as well as double bond is there, and methyl group is also there. So how we will give the name? Now when we have considered this as the longest chain, then we will see that the attachment is of 2 methyl group and alcohol group, right? So, and aldehyde is the most reactive apart from alkyl and alcohol. So numbering will start from here first. 1, 2, 3, 4, 5, 6, 7, 8, 9. So on third carbon and 7 carbon, both are methyl group attached. Clear? Then what is attached? On 7, alcohol is also there. On second, double bond is there. And on 1 is aldehyde. So our name will be 3,7-dimethyl. What we will write? 3,7 right? So third and seventh, 3,7-dimethyl Then on 7 carbon it is alcohol. So 7 alcohol. So alcohol will take only all. 7 all. Then on 1 and 2 second carbon is ene, 2 ene, and on first it is aldehyde group. So 1 al. Clear? So what is the name? 3,7-dimethyl 7-ol 2-ene 1-al. Clear everyone? The name and how to give the name, that also I think so everyone has come to know. But now what mistake we have done? What is the parent chain here? Here all attachment we have written. See, 3,7-dimethyl 7-ol 2-ene 1-al. But what about the parent chain? So parent chain should be written. Where is 7-ol? In parent chain. So what is the parent chain? Non-ene. Right? So please take this. 3,7-dimethyl non 7-ol 2-ene 1-al. Clear everyone? Okay, now come to the next. See here also parent chain 1, 2, 3, 4, 5, 6. This is not parent chain because you see it is ether, right? Oxy group here and attachment alkyl group, and this is the longest chain. So now here this is methyl attached to the oxy group, so it will be methoxy. After methoxy, how many carbons are there? 1, 2, 3, 4, 5, 6. So it is hexane. Now on hexane what is given? Where is the two group? 1 and 1 more. So what will be the name here? Methoxy hex 1, 2, 3, 4, 5. So methoxy hex 1, 5 dione, because it is in hexane, but on first position and on fifth position both are ketone group, so it will be dione. Clear? Methyl group attached with oxy, so methoxy. Now attached here carbon will be considered first, because here you see 1 and 2. So here on 2 number it will be ketone group. So and here it is on first. So we will start from here. Clear? So what will be our name? It is methoxy. Then total 1, 2, 3, 4, 5, 6 parent chain. So hex 1, 1, 2, 3, 4, 5. 1, 5 dione. Right? Clear? How to give the name? Right? Let's come to the next now. 1, 2, 3, 4, 5, 6, 7, 8. Continuous chain 8. Is there any possibility? 1, 2, 3, 4. No. Then 1, 2, 3, 4. So continuous chain 8. Here one more. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So longest is the 8. Now you see where are the branches. Here 1, 2, 3. 3, 4, 4, 5, 6. So branches is 3, 4, 6. If I will count from here, then it will be 3, 5, 6. So 3, 6 both is there, but here it will be 4 and here it will be 5. So we will go with 3, 4, 6 lowest locant. So now what will be the name? So first go for the branch. On third it is methyl group. On sixth it is methyl group. On fourth it is ethyl, as well as fourth it is iodo. So first on fourth position both are attached. So go for the alphabetical order. So A, B, C, D, E. So ethyl will come first. 4 ethyl, 4 iodo, 3, 6 dimethyl. But what is the main chain? Main chain is again octane. Clear? So what we will write here? 4-ethyl, 4-iodo, 3,6-dimethyl octane. Clear? So all the rules you have to keep in mind. 4-ethyl, 4-iodo, then on third carbon. Clear? 3 and 6. So both 3, 6, dimethyl, and now the complete series is octane. Clear how to give the name? So take care. I am very thankful for those students who are properly taking care and bringing to the notice the mistakes. Some mistakes, that diol mistake, propane 1,2 diol, that I have made intentionally. I wanted to see that whether you are bringing it to my notice or not. And here this was 3 bond I have written which was not in my notice, right? So thanks for this, and I also hope that others also please start doing practice for it. Now what is here? 1, 2, 3. 3, so propane, and it is CONH2 group, amide group. So it is normally propane amide. On first carbon only, so propane 1 amide we can write, or we just write propane amide. Clear everyone? So these are the names, and those who have written, please check whether your names are correct or not. I received 2-3 students' name, and I am very thankful and even very happy that they have written all the names correct, right? Now please practice for it, and let us now discuss some more rules. So now let us see some more structures, and these structures are called bond line structures. So first off, let us discuss what is bond line, and then we will see the nomenclature. So very simplified form of the structure formula is the condensed formula, and simplified form of the condensed formula is called a bond line formula. So we know how to write in a condensed way and in a structured way. Now we will learn bond line formula. The organic structures represented by bond line formula are called bond line structures, right? So as writing of the structures into the condensed and structure formula were time consuming, so the organic chemist, those who were studying about organic chemistry, they thought that let us write some simplified form that will not consume a time, and that is why this existed. Bond line structures are represented by only lines in a zigzag manner. It is represented accordingly in a zigzag manner just by the line. Now in this zigzag line, carbon and hydrogen atoms are not shown. We are not writing carbon and hydrogen anywhere, just putting zigzag lines. Specially written atoms in each are oxygen, chlorine, nitrogen, right? If oxygen is present, if nitrogen is present, if chlorine is present, then such or some functional group is present, then they are mentioned. Terminals. Wherever the terminals are there, the terminals denote methyl groups. And if any functional group is present, then it is mentioned in the bond order line. Now see here, this is the bond order. This terminal and this terminal, it represents that there is a methyl group CH3, CH3. And these joints, wherever these joints are there, this joints represents carbon, and as per the bond line, the required number of hydrogen is to be understood. If some functional group is present at the terminals or in between, then they are shown by their abbreviation, right? That is their short form. The line junctions denote carbon atoms bonded to appropriate number of hydrogen to satisfy the valency of carbon atoms. So in the bond line, Where joints are there, we will understand that there is a carbon, and as per the requirement of that particular substance, hydrogen is to be considered, right? Rules here for naming bond line structures does not change. It remains same as we have gone through all other rules. See here the representation here. This is the representation by bond line, but this is our structure formula. CH3, here CH3, here CH3. That means this two terminals shows CH3. And here all joints C, C, C and C. This carbon, 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 carbon. Now this carbon 1 and 2 valency is over. So H, 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 H. Here only one H because Cl, chlorine is present. So when if we are given this, we will have to give the name. Then we will have to consider this C. All C. 1, 2, 3, 4, 5, 6. So it is hexane family. Now this is CH3, this is CH3. And branch is from this side. So 1, 2. And if I count from here, 1, 2, 3, 4, 5. So I will consider 2. Then it is 2-chlorohexane. Clear? So rule does not change. Only we will have to see now about the bond line. See here, one example is taken which is written in condensed formula, structure formula as well as bond line formula. So what is this? See, pent 3-one. 1, 2, 3, 4, 5. 5 carbon in a longest chain. This side or this side, but what is here? Ketone group is in the third position. So it is 1, 2, 3, 4, 5 pent. And here, now see 1, 2, 3. Will it be 3 or 2? 1, 2, 3. Third position is the ketone group. So it will be pent 3-on. Clear? The same condensed formula is written in the structure formula CH3, CH2, C double bond O, CH2, CH3. And same is written in the bond line structure. Terminal CH3, CH3. So this CH3, this CH3, CH2, C double bond O, CH2. This is the bond line formula. Now let us see some examples over here. See here 1, 2, 3, right? And what is here? 1, 2, 3, 4. 4 carbon in a continuous chain. But here is the attachment, so I will start counting from here because 1, 2. On second carbon, alcohol is there, so but 4 carbon total. 1, 2, 3, 4. Butane 2 all. Right? If this is the bond line, how is the structure? See here. CH3, CH2, CH, CH3, OH. This is the structural and this is the condensed. CH3, CH2, CH, CH3, OH. Now see here, carboxylic acid is from this side, so we'll count this. 1, 2, 3, 4, 5, 6. Total 6. So hexane is there. Branch is on 1, 2 and 3rd. Now when this is a single line, it means the terminal here it is CH3. This is the CH3. So methyl group. So I will take 1, 2, 3. 3 methyl hex 1 oic acid. Clear? Now see here. If we count from this on second, but then 3, 4 and 5. Second and 5, 6, 7. And here what it will be? 2, 3, 4. So this side is the lowest locant. Start from here. 1, 2, 3, 4, 5, 6, 7, 8 carbon. Longest chain is 8 carbon, so octane family. Now let us see. Second and third, bromo. Fourth is chloro. Fifth, sixth, seventh is fluoro. And alphabetically, bromo comes first only. So let us go for bromo first. 2, 3 dibromo. Then 4 chloro, 7 fluoro, octane. Right? Now let us see here. If we start from here, then this group is here. And if we start from here, then it is here. Let us see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Right? So fifth position is nearby. So we will count from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is there, and now see the attachment 1, 2, 3 on fourth carbon. Terminal is here, so this is CH3 methyl. So 4 methyl DAC 5 on. Clear? 4 position attachment of methyl group, total 10 carbon. So 4 methyl DAC 5 on. Right? Here are few more. Here also you see 1, 2, 3, 4, 5, 6, 7, 8. Now if we see the attachment, then it is 1, 2, 3, 4. Right? And if we see here 1, 2, 3, 4, 5. We can see here double bond is there. So preference is given to double bond. And even preference, and then if we consider, then here it is on 1, 2, 3, 4th attachment and 4th double bond, where it is on second only, right? So total it is 8. Now attachment is on 5th carbon and it is ethyl group. See here, this is carbon, then attachment this C and joint. So and last also C, terminal methyl. So 1 and 2 carbon ethyl group. So on 5th position 5 ethyl octa 2 4 diene. On second carbon double bond, on fourth carbon double bond. So the name will be 5 ethyl octa 2 4 diene. Clear? Now pay attention, little longer. Let us continuously see where is the longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is the 10 decane. Here if we'll start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is also 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 is there. If we see from this side, here it is attachment, here it is attachment, but here is one functional group attached. So we will consider this as our chain. Now what is the thing here? See, 1, 2, 3, 4, 5, 6, 7, 8, 9. What happened? This is not carbon. So don't take mistake like this. This is amine group and here N is there, NH2. So this is our carbon. 1, 2, 3. Now on third position if you will see, then one more attachment, methyl is, and here 1 and 2 ethyl. So this is our complex. And on fourth also you will see 1, 2, 3 propyl, and here it is methyl group. So it is also complex. So complex will be written in the bracket. So third position into bracket 1 methyl, 1 and 2 ethyl, bracket close. On fourth position again on 1 methyl, 1, 2, 3 propyl. So 1 methyl, 1 propyl. This is 1 methyl ethyl. On fourth 1 methyl propyl, total DAC, and on 1 is amide. So it will be on DAC, it is amide. Now this is NH2, right? Amine group. So here will be one amine and not amide. If it is amide, then it will be with CONH2. That also we will have to take care. So DEC amine we will also write, and DEC 1 amine also will write for primary amine. DEC 1 amine. Clear? And now here it is nitro group attached, which is taking prefix, and double bond is here only. So we will count from here 1, 2, 3, 4, 5. Fourth position nitro. So 4 nitro, pent, 1 ene. Right? So this is how we will give the names to the bond line structures. Rules remain same. Only the thing here, we are not writing CH3, CH2, CH3, CH2 again and again. Instead of that, we are showing the bond line structures. And with this, I am giving you some more bond line structures. See here, these are the bond line structures. Nearly 15-16 I have given, so you will have to practice for it, and in the next video we will see its name, whether you have done right or there is some correction. Clear by the time? Thank you.